we're going to be doing KCL for node voltage. I'm sorry. This is a video as a remake of the previous video of a node voltage. The previous video has some corrections, and so we're going to correct these errors. Assuming node voltage for a simple circuit, and we're going to use KCL only. Now, what does KCL mean? That means we're going to operate off the node and not the loop. Okay, and so we're simply going to assume node A, right? And we're going to put a VA, that means the voltage of node A. Now make sure this is a small a for V, right? And what does KCL mean? Okay, so basically what we have to assume is this direction on the current to make our lives easier. Okay, and we write I1 and I2. I1 and I2 are going to come in from the side, and I3 is going to go down. These are our assumptions. Okay, now if we get a negative current, we'll switch directions, and I'll show you how that works. So first thing you want to do is at node A, we have KCL. Okay, and KCL will say some of the currents that are coming into the node equals 0. And some of the currents going into the node is positive. So there's two parts. Some of the currents into node A, in or out node A, will equal 0, and some of the currents that are coming into the, or any current that's coming into the node is positive. Based on these assumptions, is I1, when we drew I1 coming in, I2 coming in, I3 going down, I1 coming into the node? Yes. So if I1 comes in, it's simply plus I1. I2 is going into node A. That's plus I2. I3 is leaving node A. So that's minus I3 equals 0. Okay? So that's the right-hand side. So what we want to do is operate the left-hand side simultaneously to get the answer. So we're going to analyze, right? I1, I2, and I3. We're going to analyze I1, I2, and I3. And I'm writing a little small, so I'm trying to fit it all into the page for you guys. But if it's too small, let me know, and now we'll redo the video again. So at I1, okay, what do we have? We have basically, we have to analyze the drops, okay? So what we want to understand is obviously there'll be a voltage drop over the 5 ohm resistor if the current is going this way. If the current is going in this direction, which is this direction, okay, that means it's going to drop just like that, right? We've studied this. If the current is going in this direction, I'm pointing with my mechanical pencil, the current will drop from positive to negative. Current is going in this direction, this way, it will drop from positive to negative. Our I3 is going down, so it's going to drop from positive to negative. These are assumption drops. Now what we want to do is we want to circle the sign closest to each of the nodes. Now the trick to the problem, the second trick to the problem is that you'll have a V1 here. So above any source, right? Any source, you'll have a node called V1 because there's a drop. But you don't need that for these resistors here, right? Because of a source, you'll add a drop. You'll have for a source, you'll have a node. You have a central node here, and then you'll just simply leave these alone because these are not sources, okay? And so to analyze this, at I1, you simply circle the closest sign to the node. Okay, that will give us a positive V1 minus VA over the total resistance across this node, which is going to ground, right? V equals 0, right? And that is 5. At I2, you'll have, right? You'll have circle the closest sign to the node. That will give you a minus VA over the total resistance, which is 20. At I3, you'll circle the closest sign to the node, which is a VA over 10. Now, you simply plug in the values. What is V1? Well, V1 is simply 10. So that's 10 minus VA over 5. Here it's minus VA over 20. Here's VA over 10. Now, how do I handle this situation? Well, you simply plug this in here. Now, this will look hard at first, but it's really very easy. So I1 is 10 minus VA over 5. 10 minus VA over 5. Okay? I2 is simply VA minus VA over 20. I3 is a minus VA over 10 equals 0. Now I'm going to rewrite this again because I want to show you how the signs work. If you have a plus sign here, you simply take the minus VA here, and you have a minus VA over 20. Okay? Now how do you handle this situation? This looks like a very complicated fraction. Oh my God, a lot of math. It's very simple. Okay, we're going to take out our calculator. Okay? And we're going to take 10 divided by 5. 10 divided by 5 is 2. So we have a 2. Okay? Now, we assume a 1 in front of that VA. So to get this answer, you go 1 divided by 5, you get 0.2. So this is 0.2 VA. Just like that. This is 1 divided by 20. So what is 1 divided by 20? 0.05 VA minus 1 divided by 10. And I'm using a calculator for you to show you what I'm actually doing, okay? So normally you can pretty much do this in your head, but just for sake of instruction, equals 0. Gotta write that 0 real small. Now what we do is we simply sum these up. 2 plus, so what we're going to do is we're going to go 0.2, just like here, 0.2 plus, plus 0.05 plus, I'm sorry, this is wrong. 0.2 negative, where's the negative sign? I can't find the negative sign. So let's do this. 0.2 VA minus 0.1 VA plus 0.05 VA is equal to 0. Okay? So 0.2 minus 0.1 is minus 0.3 plus 0.05. 0.25. So that's 2 minus 0.25 VA equals 0. Okay? See how methodical this stuff is. Really, really simple once you make everything methodical. So now what we have is 0.25 VA is equal to minus 2. VA is equal to 2 minus 2 over minus 0.25, which is 2 over 0.25, which is what? Right? So 2 divided by 0.25 is 8 volts. Now, how do we plug 8 volts in here? Well, this is really, really easy, okay? So what we want to do is we want to go ahead and make a third portion here where we solve for I. So remember, it's kind of an interesting phenomenon. We start here with KCL, then we go here, then we go here, and we go back here, right? So what we want to do now is just plug in the values. So I1 is 10 minus VA over 0.5, which is 10 minus 8 over 5, which is 2/5, which is what? I1 is I think that's 0.4, right? Let me just double check. 0.4 amps. I2 is minus VA over 20, so that's minus 8 over 20, right? which is, let me do that again, 8 divided by 20 is minus 0.4 amps. Okay, now I3, I'm going to write down here real quick. Okay, I3 is VA over 10, which is 8 over 10, which is 0.8 amps. Now, obviously, this is 0.4 amps going in this direction. This is 0.8 amps going down. But what about this? What about this I2? Why is this negative? This negative sign is simply an implication of a direction. So let me show you how to adjust this negative sign, okay? So when I have a negative 0.4, okay, I have a negative 0.4, meaning is going into node A. This implies that, and it's going to get messy here because I'm trying to avoid this, is I2 is 0.4 amps from node A going out of node A. So this is the correct direction. So we assumed a direction going into node A, which is here, which is turns out to be negative. So the correct assumption is it's going out of node A. Okay, and I'm going to go ahead and separate this real quick to give you a clarification on how this works. So this is an interesting way to solve this problem. Okay, I hope this video helps. If you have any questions, leave it in the comment section below.